Hello everyone and welcome back to another video. In today's video we're going to be solving integrals using the method by substitution, and this is going to be basically a introduction on how to apply this method, and we're going to be practicing with a few simple exercises. Also, we're going to do a next video on this topic so we can practice a lot of exercises and completely master this method. So let's start with the basics. We'll begin with a very simple example to get the hang of this method and understand how it really works. So we have that the integral of 2x times e to the power of x squared dx. And this may seem very difficult to solve and you don't know how to start, as we have seen some formulas that you can apply, but none of these follow that general format. So this might seem a little tricky at first, but you need to pay attention to patterns and things that are similar here. We see that here we have an x to the power of 2 and here we have an 2x. And we know that if we derive x to the power of 2, we get 2x. So this is something important to take into hand when you're doing by substitution. What you want to do is call a variable. You use your by substitution, which you call h x squared, and therefore your dh will be equal to your x squared derived, so 2x dx, and now you have to isolate dx in order to substitute it here. You need to substitute both this and this. You need to substitute dx, so all you do is dx is equal to dh, and since this is a multiplication, you divide it by 2x. So now we can substitute both dx and x to the power of 2 with h and dh divided by 2x. And we get, now you will understand why we do this, 2x times e to the power of h, which you may say, oh, but we have two variables now, how do we solve this? But look now, times dh over 2x. So this multiplying here is cancelled with this dividing here, and we are left with e to the power of h, and now you'll know why we call it dh. This is derived in terms of h. We see here that we have an h, so this makes sense. And now all we have to do is, our h is basically like if it were an x, e to the power of x dx, which is just e at the power of h plus c. Now we undo our change of variable to say that our function is e to the power of h is x squared, e to the power of x squared plus c. And that is our result. If we want to double check this to see how the by substitution method works, let's take, for example, e to the power of x squared plus 3 and derive this to see if we get 2x times e to the power of x squared. So we have seen the chain rule, and we know that this is basically a function here. This is not a variable, this is a function. So e to the power of u times u prime, and then our 3 is cancelled, so plus 0. And this is equal to e to the power of u, which is x squared, times u prime, which is 2x. So yes, the by substitution method works, and we have proven so. Here we have another example, the integral of 3x times the square root of x squared plus 1. So what you basically want to do with by substitution is substitute the part that is most uncomfortable to integrate, the part that is more challenging. We have two parts here. We have our 3x and our x squared plus 1. So pause the video now if you want to try and guess or try and solve which one is the one you would derive. Well, the one you should derive is the thing inside the square root, as we have an x squared here and we have a 3x squared here. So if we derive this, we're going to get something x, and if we derive this, we will just get a constant. If we get something x, we'll cancel out all the x's. And what you want to do is cancel out all the x's and substitute it with an h. So let's do the following. H is equal to x squared plus 1. Therefore, dh, the derivative, is 2x dx, and therefore dx is equal to dh over 2x again. So now substitute this back into our integral. 3x times h dh 2x. We cancel this x with this x, and we're left with 3/2 times square root of h dh. Now, we can move this constant away. We can say this is like a derivative. You can basically ignore the constant. 3/2 times the integral of h dh, and this is basically as if we had the integral of x. To integrate this, all you do is 3/2 is basically the, we rewrite this in h to the power of 1/2 to understand it better. And now we can use the method that we had here, that was x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. So we do the same here, where our x is our h and our n is our 1/2. X to the power of 1/2 plus 1, 1/2 plus 1 divided by 1/2 plus 1 times 3/2. And this is going to be equal to 3 to the power of 1/2 plus 2/2, which would be 1, which is 3/2, divided by 1/2 plus 1, which is also 3/2, multiplied by 3/2. So we can cancel this 3/2 out with this 3/2 out, as this is multiplying, that is dividing, and we are left with x to the power of 3/2, which is basically square root of x cubed. Square root of h cubed. Now we undo our change of variable, so we have square root of our h, which is x squared plus 1, x squared plus 1 to the power of 3 plus c, of course. And that is our integral of this function. Thank you for watching. Check out my next video, in which I will be continuing to explain integrals and the method of by substitution.